Hello and welcome. In this video, we're going to do a quick overview of series circuits. So we learned that series circuits have a total resistance, we call that RT, and it's equal to the sum of all of the resistors. Right? So every resistor in the circuit, you'll just add them up. Watch out for notation on those, the kilo ohms versus the mega ohms versus just the base ohms. You got to account for all of those in your total series resistance calculations. The current in series only had one pathway. Right? And that meant that there was only one current in series. The current flows through one path from positive to negative, and to get the total series current, we need the total series resistance. The voltage in series used KVL, Kirchhoff's voltage law, and that basically says that the source voltage minus all the voltage drops in the circuit will equal out to zero. We're going to use all the voltage in the circuit across the resistance in the circuit. We know that multiple voltage sources are going to sum together. That's like the battery packs that we have, where we have to put them in a very specific order, like the back of the remote controls. So the direction matters on those, because they will subtract from each other if they are opposing. The voltage also distributes across the total resistance, and that is using the voltage divider rule. It gives us a ratio of voltage division in our circuit. And so that's this over here. It uses Ohm's law and KVL to determine the voltage drop. So the voltage drop is going to be the specific resistor that you want to know the voltage across, and we'll put that same resistor on top as what we want to know the voltage drop across, what resistance it is. On the bottom is what we have, that's our total resistance, and we multiply that by our total voltage source. So here's an example of that applied. It says the voltage across the R1 resistor. We put R1 on top as what we want to know the voltage drop across, total resistance on bottom, and then our voltage source at the end here. Power in series depends on which resistor you're looking at, so you want to make sure that you pair the current through the circuit, there's only one current in a series circuit, with the voltage drop of the specific component you want the power through. So if you want the power through R1, you need to use the total current IT and multiply that by the voltage through R1, right? Just like this one did here, it found the voltage drop across R1. The other equation that you could use for power in series would be this power equals current times resistance. That comes from the combination of Ohm's law and our power law. And that one is a little bit nicer because the current stays the same, right? So if you wanted the power across R1, you can say that you have the current IT. You can square that and multiply it by the actual resistor R1, and then you don't have to find the voltage drop across R1 using the voltage divider or an Ohm's law path. You can just straight up use the resistance value. Just make sure you account for your notation. We also recall that power is also equal to work over time, and that work is equal to power times time, and those two are going to come in later when we get into nonlinear resistances, which can also be put in series and parallel. All right, let us know if you have any questions.